This isn't lava. It isn't a predator. It doesn't chase you. It doesn't move. It doesn't even look dangerous. It's just salt. But if you cross the invisible boundary, your body shuts down in seconds. These are brine pools, underwater lakes so toxic, so dense, and so chemically extreme that anything entering them dies almost instantly. And the worst part, they've been sitting at the bottom of the ocean for millions of years, waiting. When we imagine the ocean, we picture one continuous body of water. Endless, seamless, connected, but in certain places, thousands of feet below the surface, the ocean breaks its own rules. There are lakes, not metaphorical lakes, real ones. They have shorelines, they have surfaces, they even have waves. Entire bodies of water sitting inside a larger body of water. They're called brine pools. And they are some of the most hostile environments on Earth. Not because they burn, not because they bite, but because they suffocate, poison, and preserve all at once. To understand how a lake can exist inside the ocean, you have to understand density. Water may look uniform, but small changes in temperature and salinity dramatically change how heavy it is. Normal seawater contains about 3.5% salt. Brine pools can reach 30 to 40%, 10 times saltier. At that concentration, the water becomes so dense that it behaves like a separate liquid entirely. It doesn't mix, it doesn't diffuse. It sinks into depressions on the seafloor and stays there like syrup at the bottom of a glass. Imagine pouring thick molasses into water. It doesn't instantly blend. It settles. Brine pools do the same, except this molasses kills. And once the salt concentration reaches those extreme levels, something even worse happens. Oxygen stops entering. The brine is so dense that circulation is nearly impossible. No mixing means no fresh oxygen. The pool becomes anoxic, nearly devoid of breathable oxygen. For a fish, that's catastrophic. A fish swims too close, it crosses the boundary, its gills pull in water, but there is no oxygen to extract. Within seconds, the brain begins to suffocate. Cerebral hypoxia, confusion, loss of coordination, collapse. But the salt alone isn't the only threat. Many brine pools are loaded with hydrogen sulfide, a chemical toxic to most complex life. Hydrogen sulfide interferes with cellular respiration. Even if oxygen were present, cells couldn't use it efficiently. In some pools, methane concentrations further strip away available oxygen. This isn't just salty water, it's chemically weaponized. And the most terrifying part, they don't look deadly. From a distance, a brine pool looks like a shimmering mirror on the seafloor. Calm, still beautiful, ROV cameras approach and capture what looks like a lake surface, a clear boundary between two liquids. When something breaks that surface, it ripples like normal water, but once crossed, escape becomes nearly impossible. Most healthy fish detect rising salinity through chemosensory systems and turn away. But not always. Sometimes a predator chases prey too close to the edge. Momentum carries them forward. By the time they realize the water feels wrong, their gills are already failing. Crabs and bottom dwellers sometimes slip down slopes. Young animals drift too near in the deep sea. Mistakes are final. And when they die, something strange happens. They don't rot, at least not normally. Decomposition requires oxygen and bacteria. Brine pools provide neither. The extreme salinity pulls water out of tissues through osmosis. Cells dehydrate rapidly. Moisture leaves. Salt remains. Crystals begin forming within the body. Instead of decaying in weeks, the organism becomes preserved, mummified. The salt doesn't just coat the outside, it penetrates, crystallizes inside tissues. Wounds seal as minerals form over them. The body becomes something between flesh and stone. Stable temperatures, slow chemical reactions. No oxygen limits bacteria. No currents disturb the sediment. Bodies sink and remain. Years, decades, possibly centuries. Many brine pools are surrounded by rings of preserved corpses, a silent warning marking the boundary. So how did these lakes form? To answer that, we have to go back hundreds of millions of years. During the Middle Jurassic period, regions like the Gulf of Mexico were shallow seas. Climate shifts caused evaporation to exceed rainfall. As water evaporated, salt remained. Over time, massive salt sheets formed, kilometers thick. When the seas refilled, those salt layers were buried beneath sediment, mud, sand, rock. Pressure increased. Salt behaves differently underground. It's buoyant. Under immense pressure, it flows like plastic. When seawater seeps into these domes, it dissolves exposed salt. The water becomes supersaturated, extremely dense. When that brine reaches a depression on the seafloor, it collects. A lake is born. Mediterranean brine lakes, like La Tellent Basin, formed this way, ancient oceans leaving chemical traps behind. In Antarctica, brine lakes form differently. When seawater freezes, salt cannot fit into ice crystals. It's expelled in a process called brine rejection. The expelled brine becomes denser and sinks. Sometimes it pools instead of dispersing. Another lethal lake forms in tectonically active areas like the Red Sea. Seawater seeps into fractures. It dissolves buried salt deposits, encounters magma, heats, rises. When it emerges, the superheated mineral-rich brine cools and settles into depressions. 3 formation pathways. Same result. An underwater lake that kills in seconds. Among the most infamous is the hot tub of despair in the Gulf of Mexico. Roughly 100 feet wide, about 1,000 meters deep. Salinity near 40%, near the chemical ceiling of solubility. Water can only dissolve so much salt. Beyond that, crystals form and drop out. The hot tub is brushing that limit. And despite its lethality, life exists nearby. Not fish, not large predators. Microbes, extremophiles, bacteria and archaea that do not rely on oxygen or sunlight. Instead, they metabolize sulfur, methane, and toxic chemicals. Chemosynthesis replaces photosynthesis. White microbial mats form around the edges like fuzzy carpets. Tube worms gather nearby, hosting symbiotic bacteria inside specialized organs called trophosomes. Crustaceans hover at the razor-thin boundary layer, not inside the brine, but right at the edge. Because where extreme environments meet, energy gradients form, and life exploits gradients. Brine pools are chemical frontiers, but scientists study them for another reason: astrobiology. The conditions inside brine pools: high pressure, no oxygen, extreme salinity, toxic chemistry resemble environments believed to exist beneath the icy shells of Europa and Enceladus. Ocean worlds: if life survives here, it might survive there. Brine pools are Earth's rehearsal for alien oceans. They are natural laboratories for understanding life at its limits. They may even become energy sources. The salinity gradient between normal seawater and brine creates osmotic pressure. That pressure could drive turbines, generate electricity, harness lethal chemistry as power. They are also geological time capsules. With almost no mixing, sediment layers remain undisturbed. Rainfall patterns, volcanic eruptions, earthquakes, climate shifts, stacked in perfect preservation. So, brine pools are paradoxes. Approach too closely and they kill instantly. Study them carefully and they reveal Earth's history, and possibly the universe's future. They remind us that danger doesn't need claws, it doesn't need teeth. Sometimes it just needs chemistry, an invisible boundary, and one small mistake. The ocean doesn't always kill with violence. Sometimes it kills with stillness, and at the bottom of the sea, there are lakes that wait.